looking at a general proof of quadrilaterals, okay? We're going to set up a coordinate for 4 vertices of the given parallelogram, okay? So I'm not sure why there's not a picture here, but there needs to be. So I'm going to draw it in. So I'm sorry that you guys have to sketch this on here, but I need you to do it. Okay. Yeah, and this is B0. This is A0. This is B0. This up here is 0C. Okay. And then I'm going to, in color, put my parallelogram. Okay. So here, okay, so it's a messy looking parallelogram, but what I want you to see is where these points are, okay? This point right here is at what? 0, 0, okay? So I'm going to do this in a different color. Okay, so that's at 0, 0. This point right here is supposed to be, this is at A0 right here. So this point is also at A0, this one. This point right here is at AC. AC. Everybody okay with that so far? It looks crazy, but like you're okay with copying down what I've got down? Okay. And this one, I went over A plus B more. So this should be B plus A up C. Okay? B plus, this is A more. Since A is 1, 2, 3 away, here's B, and I went 1, 2, 3 more over. So B plus C. Okay. We're going to prove, I'm just going to read. I'm not going to move it or write anything yet. We're going to prove that your coordinates construct a parallelogram. And we're going to do this by finding the slopes and the lengths of all the sides. That's what we're going to do for B. So I am going to call these points, this one right here at 0, 0, I'm going to call M. This one at AC, I'm going to call I. This one at B plus A, comma C, I'm going to call T. And this one down here at A0, I'm going to call E. Okay. Now I'm going to find the length and the slopes to all of these. So it's going to be very similar to what we did for the properties one. Okay, so I'm going to move this a little bit. I'm going to zoom this out just a tiny bit so we can have that there while we're figuring this out. Okay, so I'm going to find the length from M to E first. What's the distance from 0, 0 to A0? Now look, what does it say? Okay, so I went from 0 to A, correct? So my length is A. So there's no, I want to be clear about this because it's real confusing at first. These do not count as numbers, 1, 2, 3. We don't know how, they could be counting by 2s, they could be counting by 4s. They could, whatever. So we're going to say it as a number, a letter. So we went over A. That's all we know. Now, this is going to be the lengths on this side, and I'm going to put the slopes right here. So what's the slope from M to E? Did I go up at all? No. So I went up 0, and I went over A, right? So my slope is just 0. Okay. Let's talk about from E to T. Do you want to do the other easy one first, or do you want to do one of these hard ones? Because we can skip and go from I to T. Okay, I'm going to do E to T unless there's complaints. Okay. So I'm going from E to T. So we're just going to put this in the distance formula, just like we did for the other ones. Okay? So I'm looking at E is A comma 0, and T is B plus A comma C. So this is my X1, Y1, X2, Y2. Right? So we're going to put it in the distance formula. So we're going to say X1A minus X2, and I'm going to put that in parentheses, B plus A, squared, plus Y2, which is 0, Y1, which is 0, minus Y2, which is C, squared. Okay. If we've got, I can zoom in, sorry. If we've got A minus B plus A, we're going to end up with A minus A is 0, right? Okay, because it's this whole thing squared. So A minus A is 0, so we've got negative B squared. Which a negative times a negative is always going to be a positive, right? So do we really need to worry about this negative? No. Plus negative Z squared, C squared, which gives me C squared. So my length from E to T is B squared plus C squared square rooted. Now I'm going to find the slope. Okay? Shh. My slope is Y2 minus Y1 over X2 minus X1. What's that going to give you? What's C minus 0? C. B plus A minus C. Oops, what did I do wrong? Minus A, thank you. What's B plus A minus A? B. So there's my slope. C over B. I know. Remember, you hated the other one too when we first started. It's easy now because we did it 6, 7, 8 times and then took a quiz on it. So this will get better, I promise. Okay, so that's E to T. Now we're going to do I to T. Okay, look at the distance from I to T. Look at the distance from I to T. We're going to do the distance formula again. We're using, this is X1, Y1, X2, Y2. So we go A minus B plus A squared plus C minus C squared. Okay, so we're going to just end up with the square root. A minus A is 0, right? So we're just going to end up with B squared. And C minus C is 0. Oops, sorry. Yep, just tell me to push it up. C minus C is 0, right? So we end up with the square root of B squared. And what's the square root of B squared? Just B. So that's the length of E to T, is just B. Now we're going to find the slope. Okay, we know slope is y2 minus y1 over x2 minus x1. What's c minus c? 0. So the whole thing just has to be 0, right? If there's a 0 on top, the whole thing's 0. Okay, now we're going to do I to m. I'm going to do it over here because I ran out of room. We got to find the length and the slope. So I to m. So we're going to say the square root of a minus 0 squared plus c minus 0 squared. So we're going to get the square root of a squared plus c squared. Done. Now the slope, 0 minus c over 0 minus a. That gives me c over a, right? Negative over negative makes it a positive. Okay. Yes. Square root of b squared. Okay. What's the definition of a segment bisector? Who knows what a definition of a segment bisector is? What is a segment? It's a line that has a beginning and end, right? What does a bisector mean? Cut in half. So a segment cut in half. Okay, write the definition as a biconditional statement. So we're going to write out if it is a segment bisector, then it's a segment cut in half. So biconditional would be a segment is cut in half, yes? If and only if it's a segment bisector. Okay. Last thing we're going to do on this page is prove that the diagonals bisect each other. So if we're proving diagonals bisect each other, what formula do we need to use? What is that one called? Midpoint. We're going to use midpoint. And the midpoint formula again is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay? So we're going to have to find the midpoint of M to T and the midpoint to I to E. So the first thing I'm going to do is write down what the points for M and T are again. M is 0, 0, and T is B plus A, comma C. Okay? So this is x1, y1, x2, y2. So we're going to say 0 plus b plus a divided by 2 and 0 plus c divided by 2. What's going on, guys? Okay. So you get that these are the points for M and T, right? Is that okay? So I gave it to you up here. This is M, 0, 0. This is T, B plus A, comma C. Okay? Then it's just following the formula. We know the midpoint formula, and I'm just plugging them in. So we should have B plus A over 2, comma C over 2. Now, the only thing is we need I to E to equal the same thing. So I'm going to write down the points for I to E. So I's points are A, comma, C. E's points are A, comma, 0. So far, so good? I'm going to help you with number 2. I'm going to help you set up a square before we move on. Okay, so this is x1, y1, x2, y2. So before I move on, is there questions about that part? Okay. A plus A divided by 2, and C plus 0 divided by 2. Oh, this should be A, excuse me. Oh, this should be B0, excuse me, not A0. That's my fault. Okay, so we get A plus B divided by 2 and C divided by 2. So they are the same because A and B, A plus B is the same as B plus A. So they do bisect each other. Okay. Let's turn the page over and I'm going to help you set up your points for a general square. Before I let you do it on your own. Okay, so I want you guys to write down these two formulas because it's going to help. The distance formula is x1 minus x2 squared plus y1 minus y2 squared, square rooted. It doesn't work as well with the other one. And we have to do y2 minus y1 over x2 minus x1. Okay? That's what we're going to use for B. We've got to do both of those for everything. Now we're going to set up a little graph right here where this is the y-axis, this is the x-axis. Okay? We agree right here is 0, 0, right? So I am going to set up a square with you guys, and I highly recommend you have one corner for all of these when we do them, all of them, at 0, 0. Okay, it's going to help. So here's one at 0, 0, and we're making a square, right? So we want these the same distances apart. So here's my square. What am I going to name these points? This point right here, let's just call it A, B, C, D, okay? What are we going to call A? A, what point is it at?
0, 0.
A is at 0, 0. Okay? What about D? How much did we go over? We can't say a number because I don't have a scale set up. Instead of A, because we already have an A, let's call it X. Okay? So we went, if we go from A to D, we went over X. Did we go up anything? No, so that should be what? 0. Okay. Now we want these to be the same. So how much do I want to go? I didn't go over it all for B, but how much did I go up? X. Okay, so what would C be? I went over and up. How much? Yeah. Okay. Now you're going to find the length of all these sides. You're going to find the slopes of all of these sides. And you're going to go through and answer through H. That is today's assignment. If you, try each one, okay? I'm going to walk around and help people that need it. All right? And we are going to go over this in more detail tomorrow.